Physics Part 437. The wave traveling at 3.0 into 10 spot raised to 8 meter per second. The time taken is 0.24 seconds. The delay would be increased where the several satellites were involved and would not be acceptable during a telephonic conversation. To avoid these problems, geostationary satellites may be used in conjunction with optic fibers. Polar satellites are satellites that have low orbits and pass over the poles. The orbital period of these satellites is about 100 minutes. Since the Earth rotates below such satellites, then in any period of 24 hours, that satellite will pass over every region of the Earth's surface. Continuous communication with a single polar satellite is not possible. However, information may be transmitted to the satellite while it is overhead. The data can be stored in the satellite, then transmitted back to Earth when the satellite is over the appropriate area. Continuous communication is possible using a number of polar satellites in orbits that are inclined to one another so that at least one satellite is always above the transmitter and receiver. In this case, the aerials must track the satellites in their orbits. The advantage of using such satellites is that their orbital height is only of the order of 10 spot raised to 5 meters, a few hundred kilometers, and thus delays in telephonic conversations are not noticed. Since polar satellites pass over the whole of the Earth in any 24 hours period, they are used for remote sensing. Such uses including military espionage, geological prospecting, and weather forecasting. The Global Positioning System GPS or SAT-NAV uses the signals from a number of satellites that are not geostationary orbits. Section Summary. Information may be communicated using wire pairs, coaxial cables, radio waves, microwaves, and optic fibers. The signal attenuation, the power gain on amplification, and the signal to noise ratio are all given as ratio of two powers. The ratio is expressed logarithmically and measured in decibels, dB. Numbers of dB is equal to tens into Lg into P2 over P1. Satellite in geostationary and polar orbits are used for communication. There are section questions. The use of geostationary satellite and optic fibers for worldwide communication have, for many applications, replaced the use of skywave. Outline the use of skywaves for worldwide communication. B. Suggest reasons why geostationary satellite and optic fibers have replaced skywaves. C. Explain why a combination of geostationary satellites and optic fibers is preferable to geostationary satellites alone for communication over very long distance. Question number 2. Both wire pairs and coaxial cables are used in communication system. Suggest two uses of the wire pairs in communication system. B. Explain the structure of a coaxial cable. C. Compare the use of wire pairs and coaxial cables in communication systems. I beg your pardon, please. 3A. Question 3A. Outline the principles of communication using geostationary satellite. B. Suggest one disadvantage of using several geostationary satellites for communication between opposite sides of the Earth. 3C. Discuss the advantage and disadvantages of using polar rather than geostationary satellites for radio communication. Next section, the mobile phone system. At the end of this section, you should be able to understand, evaluate, and recall certain entities. And I would like to share them with you in my next video. So let's have the forthcoming video and then move along with it.